This speech is about UEFI, the Converged Firmware Infrastructure. So we have Dong Wei here. Dong Wei is a HP Fellow. He's an IEEE senior member, and he has extensive experience in leading the industry innovations. So Dong was actually the person who pushed the industry to invent the UEFI technology and extend the ACPI and ACPI technologies. Dong serves as the Vice President at the UEFI Forum, Inc., and Secretary of the ACPI SIG. I'll pass it on to Dong now to talk about the UEFI.
So thank you. What I have heard is that I'm the greatest devil here. Anyways, I think if you have been here last year at LinuxCon Australia, I wasn't here. But I got notified that a person named Matthew Garrett actually presented a very good session on UEFI Secure Boot, and I'm going to touch onto that topic later on in my session. And that created a lot of discussions over the year. So if you're deep into this topic, you know what I'm talking about. But I think we have two good sessions today and tomorrow. I'm going to be talking a little bit about the history of UEFI, how it's related to the secure boot, and some of the confusions that are out there. And then tomorrow, James is going to talk about how Linux Foundation is dealing with some of the secure boot aspects. So look for tomorrow morning's sessions as well. Before this topic of UEFI Secure Boot was brought up to this conference, I don't think the UEFI term was very familiar for a lot of people. So traditionally on the x86 world, we have been deeply involved in BIOS, right? So if you try to boot a system from a PC, usually you use you deal with the BIOS infrastructure. Certainly, on the ARM side, you have a different structure, U-boot or whatever have you, right? So something that bring the system up to a known state so that the operating system like Linux can start to run. So I want to talk about why we getting to this situation of using UEFI rather than just keep continuing on with BIOS or U-boot or what have you. So a lot of the motivations behind that, and a lot of them are actually very applicable to today's environment. And then I think there are a lot of confusions about there are actually many different technologies related to security. Security is always a very fancy word for a lot of people, right? The minute you talk about security, everybody jumps into it, right? So there are actually several different technologies around the topic of related to security in the areas of boot. So I want to make sure that people have a very clear understanding on a couple of different sides of the story. So that when we talk on the blog or out there, we have a very clear distinction between some of the technologies. So quickly, the motivations. So I was there in when I began at HP, we started to develop the technology called Itanium. So this is used for a very large system, in the business critical systems, in banks, in very high, large infrastructure that demands a lot of mission critical businesses that runs 99.999% of the time, right? So you can only have less than 5 minutes a year to have the system down. So when we look at that infrastructure at the time, we were initially wanting to run Windows 95 on that machine, which, as you can see, it's not a good idea. And Windows 95 at the time was based on BIOS, right? So we looked at the BIOS, and what we found was, well, Itanium, as you may know, was created as a 64-bit processor architecture, right? But you look at BIOS, it's 16-bit. Well, it's pseudo 16-bit. It's not entirely 16-bit. when you look at the memory space, it's only 1 megabyte. And you can only address 640K because somebody believed that's all the memory you need forever, right? So, and then you have a little bit of a space up there, just below 1 megabyte to execute the adding card option ROMs. And the number you can fit in, at most are 3. So you cannot boot from many devices if you keep using that mechanism. At the time, we didn't know, but we had the vision that somehow the hard drives are going to go beyond 2.2 terabyte. And today, we have 3 terabyte hard drives out there, right? But can you use that as a boot volume if you use BIOS? No, because BIOS depends on MBR. And that format has a 32-bit address in there that just points to this range that are below 2.2 terabyte. So, and then there are a lot of other things that are related to the PCA-T architecture. A lot of the hard assumptions that you made, for that machine. I/O ports. Some of the architecture you don't have I/O ports, right? And VGA. Everything has to have a VGA. Why? Linux is used in a lot of embedded spaces. Why would you have to have a VGA in that space, right? PCI, there's a limit of 256 bus numbers. Well, in the old days, it might be okay, but the minute you hit PCI Express and you're trying to build a large system of hundreds of I/O ports, I/O slots, and then you try to do hot plug of these I/O devices, it runs out of the number. And then everything has to route through this single controller called PIC, right? The interrupt controller. All the interrupt has to, goes through one device. That's not a very good way to build scalable devices. So, because of all these problems, we try to create an architecture that basically, address these limitations by, making the infrastructure more universal, extensible, and flexible. So now you know that the architecture is not limited to one processor architecture, and I'll get into that. And then you certainly can use 3 terabytes for your hard drives, and you don't have to have VGA. Let's see. So a little bit of a history on how we got to here. So like I mentioned, in about mid-90s, we created this infrastructure. And then around 2000, we figured, well, it's not good to just limit it to x86 again. To Artinian again. So we expanded that to cover x86 as well, because we want to make sure whatever we create is not limited to one single generation or one family of processors. So in 2004, we took the idea, from you guys, the free software, open source, right? So we created this open source community that deals with coming up with the implementation of this architecture. And this effort has been going on for until now. It's still going on. So in 2005, after AMD created the 64-bit extension to the x86 architecture, we defined the processor binding, and everything else doesn't have to change. You can still support PCI, USB, SATA, whatever have you, right? And then you just define a little bit of the pieces related to that 64-bit extension. And the good part of that is, when we're looking at supporting ARM, well, it's easy because we just need to define a little bit of the processor binding for ARM. And we initially did it for 32-bit, and now we're working on 64-bit. And the interesting thing is the 64-bit binding of UEFI is already done. And we cannot publish it because ARM has not published the 64-bit architecture yet. So we're waiting for them. So last year it was actually a pretty big year because I think many of you know that a lot of the PC systems, at least on the client side, had to do the UEFI implementation. So we saw a very large adoption on that front, and we now have 230 plus members in the UEFI forum, which is a non-profit organization. And we focused on boot performances, which is important in the PC systems, and we certainly also worked on the security part, which I'll cover a little bit also. And looking forward, starting from this year, we're not done. We still need to look at the ARM adoptions as well, and also we want to figure out since we think it's a very good converged infrastructure for firmware, we want to also move some of the other system configuration related or management related capabilities into this infrastructure as well. So I'm not ready to announce anything new, but I think you can look forward to some of the new things that are going to happen this year. And here's a very illustrative diagram of how things are going on the x86 front. So as you know, the 64-bit implementation of the x86 are widely adopted. I think there are only a few exceptions for the SoCs and stuff, but most of them are 64-bit. So this diagram shows comparing between the legacy BIOS implementation and the UEFI implementations. The UEFI really took off over the last few years. It was a long process. It started around 2005, and now we're kind of 7 years into it, which is a little bit surprising to me because I came from, like I said, from the Itanium world where there was no install base, right? So to change is easy. But for x86, you don't realize how much the industry is so embedded into the infrastructure. Making such a change is a very big deal, actually. So that's why we're seeing that probably at the end of the year we will see 90% of the x86 systems adopting UEFI, when you hear the term UEFI, you also have to know a little bit of a differences among a few classes of machines. The issue is that as the industry adopts these machines, they are progressively adopting it, right? So it's not overnight. Everybody, goes from UEFI goes from BIOS to UEFI. You have to, take a very gradual steps. So there were a time, a couple of years ago, a lot of machines are using UEFI code base. They're using the UEFI, implementations, but because the OSs are not ready, right? So or the adding cards are not ready. So they have to still present this thing called CSM, the compatibility support module, to, still pretend the system is BIOS, so that the OSs can run on top of them. So now you have this issue where you're going out there buying machines and say, oh, I want to support my 3 terabyte machine. And somehow this machine is supposed to be UEFI, but it doesn't support my 3 terabyte machine. Why is that? Well, that's because that machine doesn't actually expose you with the UEFI boot interfaces. It was still the BIOS interfaces that the OSs are seeing. So, there's not a very good way other than to buy Windows 8 logoed machines today to make sure that you got the right one. Because I don't know, there's not a lot of good documentation from the vendors to make sure you buy the latest one too. There's no effort by the vendors to retrofit. It's a very big effort, right? So if you already had a machine from 2 years ago and you say, oh, can you provide this new UEFI for me? No, the answer is no. Nobody is going to retrofit that. The past is gone and we're looking forward. So there are machines that are class 3, which means that there's no CSM on that machine. So you have to, everything has to be based on UEFI. There are a few of those machines around already. On the ARM side, ARM incorporated itself, the ARM proper, is also, very interested in looking at supporting the industry using the UEFI interfaces. They are a contributor in the UEFI forum. And so they have been working with us very deeply in making sure all the tools and the architecture are ready. So like I said, 32-bit binding is already there. 64-bit is defined, waiting to be published. I don't know what version number we're going to be calling it, maybe 2.4, but yeah, I'm not going to pre-announce that. So, but you can guarantee it's going to be there this year. And there's also a question from many of you out there that basically said, well, we had some, boot-related open source activities going on, and UEFI doesn't seem to provide me with a complete open source model for me. And I like that complete open source model. That actually is not related to, that has no relationship to the UEFI architecture at all. UEFI architecture itself doesn't preclude you from providing a pure open source implementation. It doesn't demand you to do that either. Okay, so, but if you look at the Tiano Core open source effort that I mentioned just on the last page, you can find that many of the implementations are actually completely open source. So those are two different questions. So the reason some of the companies are not quite providing everything in open source is having a lot to do with the IP models and everything. It doesn't have anything to do with UEFI. And I don't know if you know the Linaro effort, which is the Linux on ARM. They have a nonprofit organization that does that work as well. And in that group, there's a thing called the LEG, the Linaro Enterprise Group. Okay, so that's the group that we have been working with to, looking at implementing the UEFI grub and all that kind of interfaces for using the UEFI ARM binding. So they had some sort of a roadmap for this year, and this is actually public, so you can search and find it. Okay, so Secure Boot, and that was the issue that was brought up from last year, right? So why did we look at the Secure Boot? So if you remember when I talk about the creation of the UEFI architecture, one of the reasons that we created that was to try to make the new infrastructure to be modular, extensible, flexible, right? But by doing that, the interoperability has to happen when you actually define the interfaces for both sides of the implementations, right? The consumers and the producers have to agree on the protocols. And actually, yesterday's keynote was very interesting to me because she was talking about a lot of the, she saw the world in the protocols, right? And the version numbers and stuff like that she mentioned, it applies to the UEFI definitions quite well, actually. We were struggling on that part as well. Do you define something as a new protocol, or do you just increase the number of the version? So that's actually very, very related. So as you do the interface designs, standardize it, well, you created a problem because previously each vendor is doing their own BIOS. So you have this security through obscurity, right? People, they have to reverse engineer how you implement the thing. It takes a long time. It's not completely secure, but it takes time for people to crack your code, right? But the minute you define everything in standard interfaces, well, it's up for attacks, right? So the attack surfaces are larger, the minute you try to define these things in the standard interfaces. So what do? The BIOS side, the firmware BIOS area is very attractive to the attackers. The minute they hack that area, they don't care about you guys, right? I mean, whatever gets loaded afterward, they have complete control, right? So whatever OSs or virtual machines or hypervisors, they don't really care if they can attack the bottom side of the stack. So we saw it as a problem, and also, it was widely reported there are a number of issues already. So Phoenix, which is a BIOS company, they initiated a discussion. They said, well, that doesn't work very well. You have to create something to address the need. So there was what we call the security subteam formed within the UEFI to address this topic. And so the initial definition of it was defining 2.3 of the UEFI specification. And then Microsoft came in and said, well, we had some new ideas as well. So they changed a little bit on how you do the variable authentication, just a little bit of differences. So we kind of included that as well, as two different approaches. And then they said, oh, we would like to contribute the Authenticode specification for you to use. Well, we already had the PECOF format as the file format for UEFI before. And now they said, well, we also contribute Authenticate, which kind of makes sense to us. So we said, okay. So in Secure Boot, we basically have three components. The definition of what we call the authenticated variables, a way to authenticate variables. And then we also ask what we call the driver signing. Well, actually, it's a little bit beyond just signing the drivers. All the binaries that are related to boot would need to be signed. So driver is only one aspect of it. And you also have your OS loaders and some of the other applications that might be needed. And then there are also the system-defined variables that I will talk about a little bit. So this is an image that you are probably very familiar with, right? That's how you do the digital signing. So I'm not going to dive deep into that. So I think people are used to this mechanism already. So like I mentioned already, in 2.3 we had a counter-based authenticated variable definition, which was originally from Phoenix. And then we have this time-based authenticated variable mechanism from Microsoft. And so that you can see why we have these different differences in the protocols or the way to define these variables. And we also had the support for the append function. So all these are, bettering the design of the authenticated variables. So not a whole lot to that. If you're a security expert, you would recognize these things are needed. So like I already mentioned, the driver signing, right? The application and driver signing, the binary image signing. So in Secure Boot mechanism, what you do is every time you load the next image, you make sure it is signed, and it is signed with the keys that you recognize. And if the image is not something you recognize, the signature is not something you recognize, you don't load that image. Otherwise, you load. So the things that usually get signed are the OS loaders, of course, and then also the adding card option ROMs. Let's see. So in that UEFI mechanism, we do not deal with these the legacy BIOS side. So the minute you use the CSM, the compatibility module to load the legacy OS or use the legacy option ROMs, we don't have a way to deal with that. So that's out of the scope. So this is just a picture of how the process of how you sign the image and then how you actually verify the image. There's not a whole lot to it. It's not rocket science. Number of keys. So the way we defined it is that we have a platform key which allows you, the owner of the platform key can update the key exchange key. And then the owner of the key exchange key can update the whitelist and the blacklist, basically. The DB is containing the signatures that you allow to recognize and boot. And DBX is basically the blacklist, the things that are known to be bad. And then you also have the secure mode, which basically lets you know whether the system is in the setup mode or not. I talk about a little bit on that. So the way it works is that you can actually have the system sealed to support the secure boot, and then you can somehow have a way to break into the system and move it into what's called the setup mode. And then in that mode, you can actually change the keys, however you want to, and then you seal it again to move back to the secure boot. There's a little bit of maybe controversy or misunderstanding in that area I will touch upon as well. And so how it works at the factory, HP produces, the PCs as any other OEMs, right? So we collect the certificates from, everywhere, OSVs and partners. The trick is that, each system doesn't, all these keys would have to be in the non-volatile storage, right? But the non-volatile storage is a very precious resource. So we can't just say, we collect everybody's keys and we dump it there. We don't have that kind of resources. So the fewer the keys, the better. But that certainly created a little bit of a challenge as well. And then we load it into the system, and then we deliver to the vendors. And after the user gets the machine, if this machine is a general purpose machine, he can certainly go in there and change the keys if they want to, right? And also the OSs like Linux or any other OSs could have the ability to revoke the keys in the DB and DBX, because you may find out somebody else's program is not supposed to be loaded, and you want to make sure to block them. Okay, so like I said, we like fewer keys, from the platform vendor perspective, because all these things would have to be in the flash. So the UEFI forum actually went out there and looked for a signing service, and it's very tough. Out there, we realize that the liability is really high, and UEFI Forum is simply a non-profit organization, and the membership fees are really cheap. We should have charged a lot of money, I guess, but it's cost prohibitive for us to stand up a signing service. So we would like to work with the industry to make sure that people can sign the images. And Microsoft certainly provided a UEFI signing service, and I think for a lot of the IHV devices, that really makes a lot of sense to get them signed through that venue, and it's actually pretty cheap. It's $99 for to register that service, and then all the signings are free. So that's not a very big financial burden for the IHVs. But they also, there's a little bit of an update on their signing policies, and we actually, HP recently ran into an issue that, when we try to sign these images, right, and we had some programs that we want to sign, but then, there are a lot of issues with, because of the liability is high, and there are a lot of issues like, whether the program is of production quality, whether the program itself is going to be launching some, other applications, and that launching mechanism, whether it's secure or not. So there are a lot of questions on that areas. I'm not certain that everything is settled down in that area yet. Okay, then there's a lot of confusions out there. I think when people are implementing UEFI secure boot, because of some of the requirements coming from the OS vendors. That became a kind of a success story to some extent. Then there are other related security-related feature sets that then people kind of get confused. Which one is which? In TCG, the Trusted Computing group, there is also a feature called the measured boot, but it's also being called the trusted boot. And so now you have trusted boot, secure boot, and then Microsoft has another term called secure the boot. And so I don't know, I don't know if you guys are confused. I'm certainly confused, right? So a lot of the discussions out there that basically, centered around these discussions, and there was somebody who was saying, oh, UEFI secure boot now requires TPM. Well, no, you can certainly use TPM to implement UEFI secure boot, but UEFI secure boot doesn't require TPM. And I can show you why. So I don't know, do you know TPM? Do I need to get into TPM? It's just a hardware device that give you the capability of storing hashes and stuff. So the TCG trusted boot, you have this stack on the right and this TPM device, and I can just show you the differences. Okay, so in this trusted boot, what you have is anytime you load the next binary, you measure, you store into TPM, and then if it's okay, you transfer control, and then you measure the next one. You store the result into the TPM again, and then you load the next one. Okay, so this is how TPM, the trusted boot or measured boot works. UEFI secure boot is not that way. So we simply validate the signature for the next image, and then we transfer control. Okay, so there is a difference. That's why you see the UEFI secure boot does not depend on the TPM. But I said just minutes ago, you can actually use TPM to implement UEFI secure boot. So is that confusing? No. Why I said that? The keys, right? The keys I mentioned, the PKs, the platform keys, the key exchange keys, the DBX entries, those keys, if you want, you can measure them, and you can store the measurement into the TPM. Or you can even store the keys into the TPM, right? TPM is just a fresh kind of a device with some, random number generation capabilities and stuff. So, so I hope that, through this discussion, everybody is clear of the differences between the two technologies. They can be complementary, but they are not dependent on each other. And the other reason I have this, the solid lines below and the dashed lines above is UEFI secure boot only addresses those solid line loading. It doesn't address things up there. So that's James' task. We wash our hands clean. Okay, so because we're just doing the booting, right? We're not into how you guys load the kernel modules and stuff like that. Okay, so this is just what I said about, that no interdependencies between the two technologies, but you can complement them. You can use the TPM for both purposes. It's that. And beyond the UEFI secure boot, there's another element that I don't know if you have heard or not, because even if you put the secure boot, it's not secure, because anybody can flash the chip clean with his image if the flash utility is not secure, right? So you actually have to have a secure way of doing firmware update. And UEFI's spec actually didn't define much about how to do that, but it certainly provided some interfaces like the update capsule that you could use, but vendors doesn't have to implement that. you can have your proprietary ways of doing controlling your the firmware update. So there is in the U.S. there is this organization called NIST. It's a U.S. government-related organization that defines some BIOS protection guidelines, and in that guideline, there are elements of how you protect the firmware update mechanisms. So to have a complete story, you have to have that as well. And I think the number is called 800-147. If you search NIST 800-147, 800-147 is actually a collection of several documents, but there's one of them is related to BIOS protection. And in this reference to BIOS, it's actually a generic term. So, it's not in the contrast between the legacy BIOS and the UEFI. It's just the firmware that loads the image. Yeah, because a lot of the x86 people are familiar with BIOS, so we now, you can even run into somebody saying, oh, UEFI BIOS, right? Well, what we mean is it's using the UEFI technology to implement the firmware that boots the operating system. Okay, it's a little bit interesting. Well, because HP pays me for this trip, so it makes sense for me to show this diagram to you. But that's not the point. My point here is actually showing you that UEFI technology is not just about PCs. So we have used it in the embedded system a lot. Okay, so if you use our enterprise LaserJet, for example, it's actually using UEFI. And the very interesting story about that is that there was a period of time when we have moved from generations to generations of the LaserJet machines. And the firmware guys are not in control of the destiny, right? So HP is a hardware company, so hardware people are controlling the roadmap. So one day you're told that you're supposed to do the MIPS machine, and the next day it's PowerPC, and the next day it's Xeon or whatever, x86, and now it's ARM. So a lot of the features that they develop into the printers, if they had to redo all the designs themselves every generation, it's never going to be time to market. So what UEFI provided them was the ability, because I mentioned it is processor agnostic, right? So what they have to do is all the features that they developed, it's just a recompile and move. That moves from one processor family to the next. And so now the firmware guys are happy because they're like, well, screw you, hardware guys, whatever you want to do, I don't care, right? You create another processor family for me, well, fine. We can just recompile and implement that. So, and the same is true for some of the storage devices and the networking gears, because fundamentally these devices are computers, right? They are using some sort of processes, and if you dig deep, they are remarkably similar to a PC system, today. So, yeah, there's no magic about that. You can use the technology everywhere, and the best thing about these embedded side is you don't care about the operating system requirement, right? A lot of the times the operating system there are proprietary or very specially designed. So certainly PC is the area that implements UEFI with the Windows 8 logo I mentioned. If you want to support the 3 terabyte hard drives, make sure you get these newer machines. And you can certainly still support these. The interesting thing about the hard drive is that if you format it into MBR, then you are limited to this 2 terabyte boundary. But if you format it into the GPT, the grid partition table format, some OSs can actually recognize those drives as data drives, but they just couldn't do it with the boot volume. So if you want to use the boot volume, those hard drives, then you have to have those kind of BIOS, the UEFI BIOS support. And I sit on the board of the UEFI forum, and I got a lot of questions from everywhere, right? So people are asking, well, I have this 3 terabyte drive, and I tried to install Windows 7 or something, and all I saw was 700 gigabyte. That's actually very interesting. Think about it, right? It's not that you can still use 2 terabytes and you waste the 1 terabyte. You're actually wasting 2.3 terabyte and try to use that 700 gigabyte. The reason is just because all these, how Windows format your drive, and somehow the partitions are not laid out quite capable of supporting all the drive volumes you want. And then on the server side, certainly, like I mentioned, the Itanium system has never supported the BIOS boot, so it's class 3 from the very beginning. And the x86 servers we're working on, some of the servers will be class 3, and then even some of the the tablet formatted PCs are class 3 as well, because for some of the tablets, because you don't have to support adding cards, or maybe they are not even supporting some additional OSs. It's a very specially built device. Then you actually don't have to support the old version of the BIOS. So CSM is not required on those machines. Okay, so summary. So before you get out the door today, these are the points I want you to remember. If you can remember them, then I think I'm successful. Otherwise, I guess I need to come back again. So first thing is UEFI is platform independent. As I mentioned, it doesn't matter whether it's ARM or x86 or MIPS or or whatever have you. And UEFI Forum is not for profit. We kind of, if you actually set into that working groups in that forum, you can actually sense that a lot of people are bending backwards to accommodate people. We're actually a very good organization so far. Hopefully that that continues. Usually it's very hard. Industry standard bodies, because the vendors are partners and competitors, right? And if you're not careful, you can have a very bad taste in these kind of organizations. But so far we have been doing it very, very, very good. And a few of the Linux distros already are contributors, and we're working on getting Linux Foundation into the group as well. So we certainly welcome everybody to monitor and participate. And that's also my reason to come over here. And I also thank Bideo, because he and I were colleagues at HP before he retired. And I told him, like, I made this kind of presentations at Intel's Developers Forum, and I saw Linux guys are there. And he said, no, you have to go to the Linux forum to make sure that the messages are communicated. It works the other way, not you expect people to somehow go to the Intel forum. And so that's why I made the initial effort. This is my first time in Australia. And second time presenting in front of the Linux folks. The other one was the Linux Foundation Summit back in April. And UEFI Secure Boot is also an optional feature. Well, some OSs demanded it, but in terms of the spec, it's an optional feature. It doesn't, you don't have to implement that on all classes of machines, but I think it's a good idea to implement them because of the reasons that I mentioned. If you don't have a way to securely validate the next image that you're loading, then the vulnerability is actually higher than what you had in BIOS in some ways, because in BIOS you still have this security through obscurity, right? It's not good, but it's harder for them to break But because of our standard effort, it became easy if you don't secure the system up. And then also there are some confusions about whether or not the system allows the vendor to put their own control of the secure policy. And for general purpose machines like these, I think our position is that these machines should provide users the ability to move into the setup mode that I mentioned, and then allow the users to configure the keys, whatever they want. But there are purpose-built machines, ATM machines, for example, or the kiosk in the airport, and those guys don't want you to mess around, right? So those machines are probably locked down deep, and yeah. So those are the type of things that you have to kind of think through, and then for our platform vendors. We also have some concerns, like I think that there are some desires of keeping our, for example, I mentioned the platform key, right? There are some desires that somehow, the platform vendors keep the platform key and allow the user to somehow modify these key exchange keys and DBX keys. Well, we just, for HP, we just don't quite feel comfortable about doing that because it's our platform key, right? If you want to take over, wipe out all the keys and put your keys into it. Don't put our keys in. Don't confuse people because the platform is no longer owned by us. It's owned by you. So you need to make sure that the right keys are in there. And the last thing that I had was there are security-related features out there. There are differences, and UEFI Secure Boot and TCG Measure Boot are two different things. They can be complementary, but they are different. So make sure when you look at a lot of these press releases or blogs or whatever out there, make sure you understand the differences. Otherwise, the TPM really has some issues, right? Some countries may not like it or whatever. So we don't want to get into that. Okay, so I think that's what I have. I think it's very recent information. I try to update what I know so far. So I guess questions or?
Unfortunately, we're out of time for questions. I'm assuming Dong will be outside taking questions.
Sure, yeah, I can be available.
So if you do have questions, approach him, please. We're unfortunately out of time. We would like to thank you for the speech on behalf of the conference organisers and Linux Australia. That's just an appreciation gift.